In this module, we are going to work with raster data and figure out how to modify, import, export, create raster data in R. So just like we did last time, the first thing we want to do is import the raster package, which is obviously the most important package for working with raster data. So I'm going to go ahead and create a comment. And under that comment, we are going to use the install packages function to install the raster layer, the raster package. So let's go ahead and run that. Great. Next, we want to set the working directory for this module. And in your module data, you'll see a raster data folder. And in that's the folder that you want to set the working directory to. So let's go ahead and do that. You'll notice that sometimes if you have long lines of code like this, you may have some code that's cut off by the console. And what you can do in that situation is click soft wrap long lines. And when you do that, it'll just ensure that you can see all of the code in your window. And so it's not cut off by the console. So that's useful when you have long file names. Okay, so we've installed the important libraries, we've set the working directory. Let's import the library that we just installed. Okay, so we've imported the raster library. You'll notice that there's a couple of messages that pop up if you're using this in, 2023, early 2023, and basically there are some packages within the raster library that are going to be retired, and it may impact the performance, but that's okay. It's not relevant to us right now, so we don't need to worry about it. Now, in addition to the raster library, we're also going to import a couple more libraries, specifically the SP library. And then also the SF library. Now let's go ahead and import our first raster. We're going to jump right into it. We are going to import a raster of land surface temperature. And this is a raster of land surface temperature over Washington, and it's a .tiff file. So let's go ahead and create a variable called LST raster. We are going to use the raster function, very basic, very straightforward. And in there, you want to copy the name of the LST tiff. So let's open up the data folder so you can see what it looks like. So here's the data folder, and you'll notice that there's a file called lst_washington.tiff. That's the file that you want to import into your R environment. So I'm just going to copy the full name and import it into our script. So let's run that. Okay. I'm going to clear the console so that we can focus on this variable that we just created. Let's take a look at what it looks like. And just keep in mind that when you have a TIFF file, importing the raster really is as simple as using the raster function. So we were able to successfully import it, and we have it here in the console. So there's a lot of information here that's given to us. We can see that it's a raster layer, that's the class. The dimensions represent the total number of rows and columns, because as we know, a single raster layer is essentially a 2D data set. So you have rows and columns which is essentially X and Y. And you can see the n rows, number of rows, and number of columns. And when you multiply these two numbers, you get a total number of cells. You also have a resolution here, and that resolution essentially tells you the size of the raster cell. And the numbers here look kind of odd, and that's because it's in decimal degrees. And this is an important difference between geographic and projected coordinate systems. A projected coordinate system uses Cartesian coordinates such as x and y to represent locations on a flat surface. So you'll have a resolution of 10 meters, 30 meters, what have you. But with a geographic coordinate system, you use latitude and longitude to define locations on the Earth's surface. And that's why you may get a resolution where the numbers are a little bit odd looking. You have a lot of decimal places, and that's fine. It's still very much a valid data set. You can kind of gauge what type of coordinate system you're using based off of the extent. So you can see just by looking at the extent that we're working with latitudinal and longitudinal data. The biggest hint is given when you see the coordinate reference system, which is right here. We're using a WGS 84 coordinate system. WGS stands for World Geodetic System 84, 1984. And it's projected, and you can see long lat, which stands for longitude and latitude. And then you also have the name of the TIFF, so that's the source, the data source. And then the names represents the name of the raster layer variable. So for us, it's land surface temperature. If you had more than one raster layer, you'd have multiple names for each layer. And that's if they were combined into a raster stack. And I'll show you what that means later. And I don't think we fully covered the extent. So this is the limits of the raster data. So the x min, x max, y min, y max. So those are all really important things to know about a raster layer. If you're using raster data, it's really important that you understand the origins of the data and these parameters.